Hello friends, welcome to my YouTube channel SB Official. Today we will learn about some MCQ on power supply. And we know the heart of the power supply is the rectifier. Rectifier means it is a AC to DC converter. Before we start the MCQ session, we will learn about the basics of rectifier. In rectifier, there is a two type of rectifier. One is the half wave rectifier and another is the full wave rectifier. Half wave rectifier and the full wave rectifier is classified into two groups. One is the center trap and another is the bridge type. The basic diagrams of half wave rectifier is shown here. In case of half wave rectifier, we will use only one diode, and whenever we apply the AC in the input signal, it will pass only the one half. Whenever the diode is forward biased, then it will pass as the positive pulse to the load. That means whenever this point is positive and this point is negative, then the diode will conduct, and in output we will get these types of waveform, these types of voltage. And whenever the negative half will come across the diode, then it will behave like a open circuit. So the next half is omit at the output. Again the next cycle will come and it will pass the another positive half. So this is the waveform of half wave rectifier. Now we will come to the center trap circuit. In case of center trap circuit, we will use two diodes across the secondary of the transformer. So in this circuit, it will pass the two halves of the AC. Whenever the positive cycle will come, then the point A is positive with respect to the point B, and across the center trap portion, this is negative and this is positive. So the diode 1 will conduct and diode 2 will behave like a open circuit because the B is negative with respect to the A. So this diode number 2 is reverse bias and diode number 1 is forward biased. So it will pass the positive half cycle. Now whenever the negative half cycle will come, then the point A will negative with respect to the point B. In that case, the diode 2 will conduct because the diode 2 will forward biased, but the diode 1 is now reverse bias, but the direction of flow of current is same. So we will again receive a positive half at the same direction. So this is the output waveform of full wave rectifier. The another way of full wave rectification is the bridge method. In case of bridge method, we will use the 4 diode. So whenever the positive cycle will come across the secondary, then this point is positive and this point is negative. So the diode 3 will conduct as a forward biased and diode 4 will conduct as a forward bias. So the across the load, this point is positive and this point is negative. Whenever the next cycle will come, then this point is negative and this point is positive. So as per the cycle, now the diode 2 is forward and the diode 1 is forward. So again this point is positive and this point is negative. So at a time, for past one cycle, 2 diode will conduct at a time, and the output waveform is just like full wave rectifier across the load. So this is the basic structure of rectifier. Now we will compare these 3 types of rectifier. First we compare about the secondary voltage. In case of half wave, the secondary voltage of the transformer is Vs. In case of center trap, this voltage is 2 Vs. Again, in case of full wave rectifier, the secondary of the transformer is Vs. Only in case of center tap transformer, this voltage is double. Now, the number of diodes. We already see that in case of half wave rectifier, we use only one diode. In case of full wave rectifier, we use the 2 diode, and in case of full wave bridge rectifier, we use the 4 diode. Now comes to the peak inverse voltage, PIV. In case of half wave, the value of the PIV is Vm. In case of full wave rectifier using center tap transformer, this value is 2 Vm. Again, in case of bridge rectifier, the value of PIV is Vm. Now, ripple factor. In case of half wave, the ripple factor value of the ripple factor is 1.21. In case of full wave using center trap, the value is 0.48. And in case of bridge rectifier, the value is again same, 0.48. Now comes to the ripple frequency. The value of ripple frequency in case of half wave is f. In case of center trap, it is 2f. And in case of full bridge rectifier, it is 2f. So it will depends upon the input frequency. Now, the no load DC output. The DC output voltage, the average voltage. In case of half wave, it is Vm by pi. In case of full wave, it is 2 Vm by pi. Also in case of bridge also. Now the efficiency. In case of half wave, the efficiency is 40.6%. And in case of full wave, that is center trap or bridge, the value is 81.2%. And last one is the transformer utilization factor. In case of half wave, it is 0.287, and in case of center trap, the value is 0.693, and in case of full wave rectifier, the value is 0.812. Now comes to the MCQ questions. The first question is the rectifier converts. Option is DC to AC, low voltage to high voltage, AC to DC, and the last one is low power to high power. So already we know the rectifier converts the AC signal into DC. So the option is AC to DC. The next one, in half wave rectifier, the load current flow for. In half wave rectifier, the load current flows for option A, to complete the cycle of the input signal, only the positive half cycle of the input signal, less than a half cycle of the input signal, and the last one is more than a half cycle but less than the complete cycle of the signal. So the answer is only the positive half cycle of the input signal. We already discussed the matter all. Now the next one. Question number 3. In a full wave rectifier, the current in each of the diode flows for option A, complete cycle of the input signal, half cycle of the input signal, more than the half cycle but less than the full cycle, and the last one is 0 time. The answer is half cycle of the input signal. Okay. The next question. In full wave rectifier, DC voltage is dropped across. Actually, whenever the rectifier is switched on, the diode behaves like a closed path. Now the option is the transformer, 2 diodes, a single diode, and the last one is the load resistance. Here also stated the DC voltage. So the answer is the load resistance. Across the load resistance, the voltage drop will occur. Now the question number 5. Which of the following circuit cannot be operated directly from the main? The option A is the bridge rectifier, option B is the center trap rectifier, option C is the half wave rectifier, and the option D is voltage doubler. So here answer is the center tap rectifier. Actually center tap means center tap transformer, and by using center tap transformer, we whenever we made the rectifier, then it is known as the center trap rectifier. Okay. The next question. The bridge rectifier is preferred to an ordinary 2 diodes full wave rectifier because it uses 4 diodes, the transformer has no center trap, it needs a much smaller transformer for the same output, and the last one is it has a higher safety factor. The answer is option C. It needs a much smaller transformer for the same output. The next one, the ripple frequency of the output waveform of a bridge rectifier when fed with a 50 Hz sine wave. And the option is option A 100 Hz, option B 25 Hz, option C 50 Hz, and the option D is 0 Hz. So in this case the answer is option A 100 Hz. Actually, whenever we given the input frequency 50 Hz, the output frequency is double in case of bridge rectifier. So it will be 50 into 2. So the answer is 100 Hz. Now the question number 8. A higher ripple frequency signifies that the output is closer to DC, the power supply is not good. Option C, the output has a greater number of AC components, and the option D is none of the above is correct. The answer is option A, the output is closer to DC. Higher ripple frequency means output is closer to DC. Question number 9. Under the best condition, the rectification ratio of a half wave rectifier is option A 0.406, option B 4.06, option C 2.03, and the option D is 0.812. Here the answer is option A 0.406. Now the next one. The efficiency of rectifier is more for a efficiency of a rectification is more for a full wave rectifier, option A, option B large load resistance, option C half wave rectifier, option D small load resistance, and the answer is option A full wave rectifier. Full wave rectifier efficiency is higher in full wave rectifier. Now the question number 11. In a DC supply, the transformer utilization factor is defined by option A transformer secondary power, by transformer primary power, option B DC power delivered to the load by AC rating of the transformer secondary, option C DC power delivered to the load by AC power from the transformer secondary, and the last one is the none of the above, and the answer is option B DC power delivered to the load by AC rating of the transformer secondary. And the last question is, while comparing transformer utilization factor, the bridge rectifier has a transformer utilization factor option A better than the conventional full wave rectifier, less than that of the conventional full wave rectifier, option C which is the highest of the all rectifier, and the option D is which is none of the above, and the answer is option A better than that of the conventional full wave rectifier. So guys, that's all for the day, and the next part will come in my next video. So kindly guys, please like and subscribe my channel and share the video with your friends and give your valuable comments in the comment section. Okay, thank you for watching my channel.